If you're taking a college physics class and you're using kinematic equations, or even high school physics class and you're using kinematic equations, probably the best thing you can do is just memorize them. If you know, there's actually six of them, but if you memorize these three, you can derive these three from those three. So honestly, you only need to memorize three if you just use your simple algebraic determinations to get these. One of the simplest ways to understand how these kinematic equations work is when you have, let's just say that you are in a building and you're on the top floor. Sometimes this was used as the two college students that are trying to get their laundry down to the first floor as quickly as possible. One student will take the laundry down the elevator or the stairwell. The other student says, "Hey, I'm just gonna drop my laundry bag down and it'll get down to the ground quicker," which is true. It actually is true. So let's look at this in the sense of using the kinematic equations. I know I'm going to separate my initial conditions and my final conditions, so I know my velocity initial in the x direction is going to be equal to 0. I know my velocity initial in the y direction is also going to be 0. Okay, so this is both feet per second, feet per second. All right, so my velocity final down here is going to be in the y direction, and it's going to be some number. All right, since I know there's no x direction movement, I know that I'm going to have only velocity in the y direction. How would we do that? I would probably use this equation right here, so we know that my velocity final, I'm not going to put in all my y's, I'm just going to put velocity final squared, because I know this is my velocity final, is going to be equal to my velocity initial plus 2 times a times d. I know both cases, doesn't matter what I'm talking about, but I know I'm talking about in the y world. So I know this thing here, this is a squared by the way, I know this thing here is 0. So I know that my velocity final is going to be equal to 2 times the acceleration times the d. And we're going to take the square root of that thing once you do the algebra. All right, so how would we find that? We simply just take velocity final is going to be equal to 2 times my pull of gravity over here. I'm going to say it's 32.2 feet per second squared. I don't care if you use metric. You can use the metric system. The reasoning is still the same. Let's just say that this building is 300 feet in the air. From here to here is 300 feet. All right, so let's just say 2 times my acceleration, which is negative 32.2 feet per second squared, times my distance. Now, when I measure the distance, I'm going to be measured downward, so I got to make that a negative because we don't want a negative under the sign. 300 feet. And we're going to take the square root. Yes, we don't want a negative under the square root because then it gets too complicated. So now my velocity final, I take this and multiply it all together, take the square root, I get 138.99 feet per second. So I know this is 138.99 feet per second. So I found my final velocity in the y direction. 138, so that's pretty good speed. This is a 9, sorry. Pretty good speed for just dropping a laundry bag from top of a building. Let's see how much time it took to do that. Well, I wouldn't want to use this equation again to see how much time it took. I wouldn't want to use it because it only has distance in it. And I can use this equation, but I'd rather use this equation. It's a little bit easier. So let's look at that. Velocity final is going to be equal to my velocity initial plus a times t. It's basically this thing right here. So I know my velocity final is 138.99 feet per second is going to be equal to my velocity initial. My velocity initial, both in the x and the y direction, is 0, so it doesn't matter. And my acceleration is negative 32.2 feet per second squared times my time. Now, there is no such thing as negative time in this little simple explanation. Maybe there is in the quantum world, but we're not in that. We're in the simple little explanation. So I know that if I divide this both by negative 32.2, both sides by negative 32.2, I'm going to get a negative time. So I can't have that. This has to be negative or we just take that as being a positive. Either way. So if we divide both sides by 32.2, we get a time that's going to be equal to about 4.32 seconds. So I know the amount of time it took was about 4.32 seconds. All right, we can use this. I'll use this in the next example. We can use that. It's a little more complicated, but it will give you the same results. All right, so that's a really simple way of looking how these kinematic equations work. Let's just say now that the person decides to throw it downwards. So we're going to have a velocity initial in the y direction. Let's just say it's 20 feet per second. All right. One of the first things we got to understand, this is 20 feet per second. One of the first things we have to understand is we just don't take 20 and add it to this and call that the velocity final in the y direction. That is just definitely wrong. If you take this velocity initial y direction, you add it to this number, you are not going to get the correct answer. Let's see how this works. So again, we're going to use this we're going to use this equation. So my velocity final squared is going to be equal to my velocity initial squared plus my 2 times the acceleration times the distance. I'm looking for velocity final, so my velocity final squared is going to be to my velocity initial. Now my velocity initial in the y direction is going to be 20 feet per second, and don't forget to square that, plus 2 times my acceleration, which is negative 32.2 feet per second squared, times my distance, which is negative 300 feet. And we're going to take the square root of both sides. And again, we do not want any negatives under that square root. So my velocity final, when we take all this whole thing and we do all of the math in here, we get about the final velocity to be about 140.43 feet per second. So I know now that the velocity final over here in the second time through is 140.43 feet per second. So this is going to be 140.43 feet per second. Notice that this is not 20 plus that. This number is not this plus that, which I've seen so many times. Now let's find the time. Let's find the time it takes for it to fall. Again, we can use the simple equation, which would be this one right here. This is a nice, easier equation, but we'll see what happens when we use the other equation. So my velocity final is going to be equal to my velocity initial plus a times t, the acceleration that it falls under and how much time it falls under that acceleration. So I know my velocity final is 140.43 feet per second is going to be equal to 20 feet per second times my a times t. I'm running out of room, sorry. Which should be 32.2 times whatever I'm looking for. In fact, I'll just do it. I'll make it easier. 140.43 feet per second is going to be equal to 20 feet per second plus negative 32.2 feet per second squared times my time. Now, again, well, let's just go ahead. So I'm going to subtract 20 from both sides, right? I'm going to subtract 20 from both sides. Then I'm going to divide by negative 32.2. But again, we're back to the same situation. Do we have negative time? No, there's no such thing as negative time in this simple idea. So I know that when I solve for my t, I'm going to get a time that's going to be about 3.74 seconds. Right? So my time now is 3.74 seconds. All right, so look at the difference between these two. When you throw this down, you don't really get that much more velocity, and it's only by maybe a half a second more. So the reason why this number is not really, the reason why you don't add these two numbers and this is really high is because gravity just does not have enough time to work on the whatever's dropping, right? So you're talking about a half a second here, a half a second difference between these two. So gravity only has like a half a second more to get the velocity going faster on this side of things. I hope that makes sense. But the most important part of understanding these equations is just not to take this and add it to that. Don't do that. It doesn't work. All right, so let's look at it a little bit more complicated, find time in a little bit more complicated way. I'm going to erase this. So let's use this to find time, which is a little bit more complicated. Now, there's my y direction in this case is 300 feet. My y initial up here, I'm going to say is 0, so I'm just going to say that to be 0. And this, my velocity initial is going to be, let's see, what would we say, 20? My velocity initial is 20? Sure, it's 20. So this is 20 feet per second, so I know this is 20 feet per second times my time, and then plus 1/2 of the acceleration plus 1/2 of this acceleration. I know my g is negative 32.2 feet per second squared, so I put this in here. 1/2 of 32 is negative 16.1 feet per second. And I know that I'm going to take that times my time squared. So basically I use this kinematic equation. All right, now to understand this, I mean, we can take this as this negative away. You can say this is going to be negative, right? If we put this as negative and that is negative, you get the same results as if you take the negatives away in this case. You can do it either way. I'm just going to do it. It's just easier when you take the negatives away. You get the same result. You get the same time. So I'm just going to eliminate the negatives because sometimes when you have negatives in there, it can mess things up. I'm not a mathematician, so maybe the math kids that are looking at this right now say, no, don't do that. Well, you know, in this case you can, because I already went through it so many times before that I understand that in this case you can take the negative out and it's still going to get the same results. Okay, so let's solve this thing. It's basically a quadratic equation. So we're going to have 16.1 t squared plus 20 t minus our 300, because we're going to take the 300 and put it over here. So minus 300. You're going to get the same results if you make this negative and that negative. All right. All right, so we're going to use the quadratic equation to solve this thing. This is going to be equal to 0, so we're going to use our negative b plus or minus b squared minus 4ac square root divided by 2a. We're going to use that to solve this thing. Might end up using some of this area down here. So let's solve it. So our negative b would be our negative 20 plus or minus 20 squared plus our 4 times a, which is 16.1 times negative 300. We're going to take the square root of that thing and we're going to divide it by 2 times 16.1. And this is going to be equal to our t. Let's keep on going. We have negative 20 plus or minus. This ends up being 400 minus 4 times 116 or 16.1 times negative 300. Square root of that thing divided by 32.2. 32.2. Keep on going. let's say that this thing here, once you do all this math in here, once you multiply this all out, this 16.1, and this, fortunately, this is a negative, so this ends up being a positive. You end up adding these two numbers. You get a time you're going to get two times. You're going to get a time that's 4.98, and then you're going to get a time that's 3.74. We know this is our answer. We know this is wrong because it's too much time, simply from our first problem that we did. So you can use this equation if you like. There's a little bit more stuff you got to do. If you do use this equation, be very, very careful. Watch your negative signs. You can put the negative signs in. You don't necessarily have to, but you can if you want to. Once you do all this algebra, you'll get the same answers if you use this equation right here. I hope that helps. I mean, it's really a simple explanation of the kinematic equations. Like I said, if you're in high school or in a 100 level college physics class, probably the best thing you can do is just memorize it. It's just so much easier. It makes life easier. I hope that helps you. Thank you. And if you like, you can subscribe.